This is A-level Computer Science 961 paper 4, and in this video we are going to cover OOP. So this is our main target. We're going to cover OOP, and we will cover inside class access modifier, and also we're going to cover this exception handling and file processing as well. Okay, so let's start right from the beginning. So what is OOP? OOP is known as object oriented programming. Object oriented programming. It's telling us that there's a concept of classes and objects. Okay, class means a blueprint. And then using that blueprint we can make objects, lots of objects. We only need one blueprint, one map, okay, that could tell us that what are the properties and methods of that particular objects. Okay, so the class is known as a blueprint. It contains attributes such as string, integer, boolean, real, char, date, array, and it also contains user defined data types such as, for example, human is a class, and I'm just creating an object h1. This is also an attribute. Okay, these are attributes known as methods are those which we telling us what this class, what the object would do. So there are so many methods. Okay, we will discuss this later. And then we have encapsulation, which is data hiding, returns, constructor, destructor. We will going to see this right now. So let's get started. Okay, right here in front of you, first of all let's understand about let me just all right, yeah, this is what I wanted. Okay, so I've made this is my project. This is the Eclipse. I'm going to start with Java. Okay, and let me what smaller 8 not good enough 3. Okay, it's this one. This works perfect. All right, so this is Eclipse, and I'm going to start with Java. So what I've done, first of all, I just created a project. Inside project we have bunch of classes. Okay, so right now I've created the class name, which is task1 is the name of my class. Okay, now this is actually the main class. Okay, this is the main class. So this is my project. Inside project I will keep on creating new class and keep on adding into the project. So right now this is my main class, and inside a main class I have this main method, which is public static void main. Okay, public, this is a access modifier. We will discuss this later. Static, we will discuss this later as well. Void means does not return anything. Does not return anything. And then main is the name. It's a method name. Okay, and then it's passing a string. Don't worry about it. And now what I want to tell this, inside this method everything will be executed. Okay, so for example, if I just write down system.out.println hello, it will execute this method. Whatever it is contained inside this method, everything will be executed. Okay, let me show you how. So if I just try to run it, it will give hello world, hello. So whatever, if I put anything like hello, okay, hello, and then control space enter, and welcome Wbaatz YouTube channel. Okay, and I just save this and I just run it, and it will be run. Okay, so this is how it's happening. So class, this is the main. Okay, and whenever you try to make a class, it must match, the name must match. Okay, task1. If we try to change this name, then it will not run, it will give an error. And every time you create a task, it must have a main method, and inside the main method everything will be executed only inside the main method. Okay, now let me create another class. So what I just tell you, that class is a blueprint. So I'm going to create a class. The name of a class will be human. Okay, so class human. Inside a class we will have attributes and we will have methods. For example, my attributes would be what is the age of the human being, int age. Okay, int name, int, oh wait, not int, actually this is string. So string name, and then I will get let's say the color of skin. Okay, again it's going to be color, skin color is skin color. Okay, so I got the integer this, so that this is these attributes. Okay, let me let's say the boolean is adult, whether a human being is an adult or just a child or a teenager. This is a boolean. Okay, now I'm going to write down methods. So these are attributes, and then I'm going to put the access modifiers, which is public, 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 okay, and then public. Okay, now I'm going to create some methods. So method like, for example, public void. Void means it doesn't return anything. Walk, it will walk. And I'm going to say that I am walking. Okay, let's make another method and it will return something. I will write down int and walking, or I will just say calc walk distance. Okay, and it will okay, why is this giving an error? Because we didn't put this. Okay, I'm going to put D. Okay, and then I'm going to say that okay, int wait int temp is equal to distance multiply by wait let's say this is the speed. Okay, and I'm going to say that the time int time is how much time covered. Let's say time covered, then I'm going to say, let's say 30 seconds. Okay, and then I'm going to result, let me just say this is result. This is a result, so result is equal to d multiplied by time as such. Okay, and it will return this, return result. Okay, so these are methods. Walk, talk, all of these are methods. I'm just going to create only two of these. Okay, and these are attributes, and then I'm going to create an object. So let me create an object, and also I can create as many objects as I want to do. So human h1 is equals to new human. Okay, and then h1 dot wait int answer is equals to h1 dot calculate what, let's say the speed is 3 meter per second, then to calculate the result, and then sys out, I'm going to say, now it will give the answer. So let me just run it. There you go, it gives 90. 3 multiplied by 30 is 90 meters. Okay, 3 meter per second. I've walked, the time it took me was 30 seconds covered, and then multiply that and then returning the value. It is stored in here, and then I just make a print. Okay, let me just break it down slowly. What have I done here? Okay, let me just make it smaller. Appearance, zoom out, better, and come to the drawing. Okay. Okay. So this is my class. This is the main class. Okay, this is the main class. Inside a main class, you have a main method. The curly brackets of the main class are here to here, which means it's here to here, and then the main method is in here to here. Whenever we try to execute something, whenever we try to create object and then playing with that object, we're doing the code, we always do in here, in this main method. Okay, we always doing here, doing all the coding and stuff in here, always creating the objects, and whatever kind of execution you wanted to do, you will do in here, only in here. The main method, the main class is only used to find out the main method. So it's a backend completely. So I'm not going to that. It would just, it's a it's a complete different. For now, let's just say that this is the main class, and inside the main class you will have a main method, and inside a main method you will do some coding, and then it will execute from here. Okay, so let me just start from the beginning. After creating a project, this is my project. I have created a class, the main class. The main class comes here, and inside the main class you have a main method. Okay, now what I have done here, I have just created my another class. Okay, so this is my another class, and it's outside the curly bracket of the main class. It is outside. The curly brackets are here to here. The another class is after I have created. It's if below this curly bracket. So class human, and inside this class human I have these attributes, like for example, what is the age, what is the name, what is the skin color, and is that human being an adult or a teenager or just a child. For now I'll just write down 4 of these just to tell you that this is how you try to write down attributes. These are attributes, and these are access modifiers. It could be public, it could be private, it could be protected. I will show you why are we using this. Okay, don't worry. These are methods. Public void means it doesn't return anything, and public int means that it is returning an integer. Procedure function. Okay, public. If you want to, we can just put private, and if you want to, we can make protected. Okay, so these are all methods. It is returning something. So methods and attributes. Now inside here I have created an object. Human is a class name. Okay, let me just clear this thing. Now human is the name of my class. This is human. How do we create an object? We put a class name, then we put the name of an object. Okay, is equals to new keyword. New keyword. Why do we use new? Why do we use new? We use it to create a memory for an object. Create a memory inside a heap memory for an object. After creating a memory, then we call a constructor, which is the constructor is human. This is a constructor. Okay, this is a constructor. And why do we use a constructor? Why do we call it? We call it because it is initializing the values of the attributes. It is initializing it. It's constructing a memory actually. You can say it is constructing a memory. And there are so many types of constructor, but for now let's just stick with object and class, and then I'm going to tell you about encapsulation. But for now let's just say that constructor is used to constructing the memory. Okay, we got a class name, we got the object. We can make so many objects. Is equals to new is used to create a memory for this object, and then human, which is a constructor class, it is a method. You can say it is the constructor is also you can say a method. It's a method that is used to construct the memory, initializing the variables. Okay, that's the difference. Now let me just tell you about encapsulation. Let me just tell you about what is encapsulation, and we're going to discuss about access modifiers as well. We will discuss about access modifiers. Okay, I can make as many objects as I wanted to. Human h2 is equals to new human. Okay, so there are so many objects I can create. And for example, okay, let me just show you why do we use these. Public means that you can access these variables outside the class. After creating an object, I can access these now because they are public. For example, h1 dot, you can see here, age is adult, name, skin. I can access these and I can change the values like 55. Okay, and if I want to, I can access this as well, and this is 32. Okay, and then I can just say h1 contains, I'll put plus h1 dot age. h2 contains, then put plus and h2 dot age. And I have if I just try to run it, I will get the values. h1 contains 55, h2 contains 32. Okay. Okay. For example, okay, so you guys understand about, okay, let me just, if I make this private, what will happen? If I make this private, then I cannot access these, because it's saying that this attribute must be accessible within a class, inside a class. But if I put a public access modifier, then I can access these public to the whole world. You can access these attributes from the class. These attributes can be accessed outside the class, and private means that these attributes can be accessed inside the class. Okay, so for now let me just make private. Okay, how about if I make this protected? I can access these, but it means that it must be in a same package. What is my package name? This package. Okay, I can access these attributes if they are in the same package. There are so many different types of package. Each package contains classes and objects. Okay, right now this is my package, and it contains a class human being, and inside class human being I got this attribute age, and it is saying that it is protected. Okay, so these are access modifiers. And okay, now let me tell you about how to use these constructor. How does it work? Let me make this public for now. Okay, now there are two types of constructors. Okay, we have discussed this. Class is a blueprint. Encapsulation, we will come to that later. New keyword. Insert a class by allocating memory for a new object and returning a reference to that memory. Okay, so whenever we try to write new, it means it is creating a memory for the object and returning a reference to that memory, and it is stored into that like the object. Like for example, class name, or for example, human being, class human, and I got h1. So when I type in new, so this is actually returning a reference which is stored in here. reference. The reference is stored in here. Okay. Allocate the memory at runtime. All objects occupying memory in the heap area. Invoke the object constructor. What is a constructor? It construct the memory. Okay. Now there are two types of constructor. One is a default constructor, which just initialize the data at default values. If user meet the constructor, default constructor will not be given. So if the user meet the constructor, which means we can call it user defined constructor. And there are two types of user defined. Actually there are three types, but according to you guys, according to the syllabus, it is two types. Okay. Null constructor is something that doesn't it's empty. Okay, it is empty. I haven't put anything in here. That's a null constructor. Oh wait, null constructor is something that it's not accepting anything, and we can write it down code. Okay, so that's a null constructor, not anything except giving memory. Parameterized constructor is when you're giving parameters inside a constructor. You can make multiple constructor, which is known as constructor chaining. Okay, let me show you how. Let me just talk to you about constructor. So we discuss about attribute, discuss about method. We'll cover encapsulation later. Let's discuss about constructors, and there are so many types of constructor. Okay, so let me create a constructor. How do we create a constructor? Okay, so public human, and there you go, we have created a constructor. If I run it, nothing will give an error, hoping it will not give an error. That's why I just called a constructor. If I remove this public, and if I just run it, then it will run. Okay, if I put anything in here, hello there, I am user defined null constructor. I'm just doing my job. So constructor also act like a method. It will run automatically at runtime. Whenever we try to this is how we try to call a constructor. We are calling it. Okay, calling this will trigger and this will run. So if I just run it, then hello, I'm user defined constructor. Okay, I just called 2 times because I have created human beings 2 times. So yeah, hello there, I'm user defined null constructor. Okay, if for example we do not mention, if the constructor is definitely required to create an object. If for example we do not create a constructor, the compiler will make a constructor for you. It will be there whether you will put it or not. But if you try to put it, then your intentions might be that you want to make some changes. Like for example, you want to do something like that. Every time the constructor is called, I want to do this, or I want this code to be executed. Okay, for example, int a b, and then I'll say that a is equals to 5, b is equals to 7, and int sum is equals to a plus b. Okay, and then I'll just say the sum is this, so this is the sum. So if whenever I try to create a constructor, so the constructor will be triggered, it will execute these codes. So I run this, we'll say the num is 12, the num is 12 again. I think you should give 2 times. Yeah, the sum is 12. Okay, so this is a null constructor. Now I can create another constructor as well. Just put public just in case. Let me create another constructor. Public human. Let's say I will take int a, int b. Or you know what? I'm just taking a. Then okay, the spelling is wrong. Human. I will try to set the age. Okay, So this is a parameterized constructor because I have put a parameter. If I put okay, so this dot age is equals to 8. Okay, and if I put a number, if I change, for example, if I just leave it here, I didn't put anything in the constructor, then this constructor will be called. But if I put something, that this constructor will be called. And if I wanted to, I can make so many constructor. Okay, I can make so many constructor. I can just say that int a, int c, this is another constructor. I can put int a string c, then it will make another constructor. I can make so many variations of constructor, and depending on my input, depending whether I want to put or not, if I do not put anything, if I leave it blank, then the null constructor will be called. But if I put any parameters according to the sequence, like if I put only one, if I put only integer, this constructor will be called. And if I put two nums, like two integers like 2 and 4, then this constructor will be called. Any one of these constructor must be called depending on the user, depending on the input of the user. Okay, so again I'm creating another one. I'm just going to cut and paste in here, and I'm going to take this and put in here. So already defined, so no need. Okay, now I'm going to, why am I getting an error? Cannot be resolved to a what? This is, okay, should be C. There you go. Now if I put 5, 55, 77, what on earth? Okay, and if I put 23, okay, the sum is 12. Sum is 12, which means I have called this constructor. This constructor has been executed. Okay, and there are so many things. And if I just put only one integer, then this constructor will be called. I just initialize the age. So for example, age h2 dot age h2 is just 32. Or wait, if I just remove this, and if I run this again, it will be 23. So I have just initialized the values of the variables. So constructor is basically used for initializing, and also we can use it for executing extra stuff. Okay, so that's a constructor. Okay, okay, so that was the constructor. There are so many types of constructors. I just showed you guys that constructor. There are so many types. One is a null constructor. We do not there are no parameters. Okay, null constructor. There is a default constructor that if a user does not create any constructor, then the compiler will create it for you. Okay, the constructor is required definitely in order to initialize the values of the attributes. So default constructor. And then we got parameterized constructor. Okay, now let's come to encapsulation. So we discussed about constructor, we discussed about object, we are coming, and well, there are so many things. But let's just start from encapsulation. Okay, so how do we use encapsulation? What is encapsulation? Let me just remove all of this. Let's suppose we have created an object. There's only one object, and just remove all of this, or maybe not. Okay, number one, when we are dealing with encapsulation, and that is step number one, make all attributes private. We are talking about encapsulation. make all attributes private. Number 2, create setters and getters methods. Okay, so let's begin. Okay, so let me just start from here. I will just private. Let me just do it fast. Copy, paste. Okay, now in order to create set, I've just make all my attributes private. Okay, the reason why we do encapsulation, just to protect our data. Okay, we know this data is very important, so we want to protect this at all costs. We need to make sure that it must be accessible within a class, and then we use methods to get the information from the class. Okay, after creating an object. Setters, which means setting the data through a method. Setters and getters are methods, and through these methods we can set the data known as setter, and we can get the data known as getter. So for example, public void, I guess, yeah, public void set age, set my age, and I'll just say int a, and I'm just going to, so I'm setting my age. That's how I set things. And then I'm going to public int, I'm getting the data, public int get my age, so I'm just going to get my age, and it will return this dot. Okay, the reason why I'm using this is just to it gives me a good feeling whenever I try to use this. It just gives me a list of these attributes, so if you do not want to use it, then you can just do it directly. Okay, it doesn't matter. So I'm returning the value age. So this is encapsulation. So I've created this. If I just say h1 dot, I'm not getting the attributes, I have to use the method. So first I'm going to say set my age, setting the age 55, and then getting the age. But before that, let's just, okay, h1 dot get my age plus is my age. Okay, so get my age is the getter, and this is the setter. If I run it, it will say 55 is my age. So this is encapsulation. This you can see this how I'm using only method to access the data to change. I'm using the method to change the data, and I'm using another method, getter, to get the data. Okay, now let me give you a shortcut that if you ever wanted to create setter and getters automatically, I'm just going to, let me just remove all of this. Here's what I'm going to do. Right click, going to source, and then generate setters and getters. Then I just put this, and I'm just say this is public. All the access modifiers are private actually. So okay, sorry, should have made public. Doing again, source, getters and setters, I'm just going to put public, get everything, get age, set age, yeah, that's right. And there you go, I've created the setters and getters. Get age, set age, get name, set name. So many setters and getters for each variable. Okay, so this is encapsulation. Let's move on. Let's just move on. All right, so we discussed about access modifiers, we also discussed about objects, discuss about encapsulation. Okay, so it promotes data hiding, okay, it increases data protection, data hiding. Destructor is whenever we try to use constructor, like constructor is used to construct a memory, destructor is used to destroy the memory. Destructor is used to destroy the memory. And how do we try to destroy this? Destroy the object. Okay, actually it's used to destroy the object. Destroy the object, which means releasing the memory occupied by the object. So destroying the object and release space that was occupied. How do we destroy this? For example, first of all, we try to create an object. Tank is the class name, t1 is the object name, is equals to new. We use the new keyword to allocate memory to the object, and then tank is the constructor, constructing the memory of the object. t1.finalize is a method used by a GRE whenever we try to whenever we try to destroy the object. You can just forget this for now, even though we use this. The best way to destroy the memory is by this t1.null. t1 is equals to null. So if you create, for example, my object was human h1. If I want to destroy this, I've just put null. That's it. And then the memory can be released by system.gc, which is a garbage collector which acts like a destructor. Okay. Finalize, we use finalize is also called automatically after the object is destroyed. Okay, so the finalize method also is called automatically. Okay, even if we don't call it, it doesn't matter. The compiler do all the stuff. That's why in Java we don't do anything extra like system.gc or .finalize. These things are called automatically done by the Java compiler. Our job is to just destroy this and just by doing null. t1 is equals to null, and there you go, the object is destroyed. The system.gc will just release the space that was occupied, and t1.finalize will tell that yes, the object is destroyed. Okay, so this is destructor. The concept of destructor is quite different in Python and in C++. That's why destructor name is known. In Java it's quite different because we only just try to put null and then the object is destroyed, and system.gc acts like a destructor. Okay, the destructor is used to just destroy the object and then release the space. Okay, in Java it's quite different. Just for general knowledge, I just told you guys. Okay, now moving on. Okay, so class and inside we just override the method. We will know what is overridden. It's come in polymorphism, but we have just created this just to override the method. Okay, let's just forget about this. Okay, so we also discussed about access modifiers. We know that accessible to anyone, accessible within a same class, and accessible within the same package, and from access from outside the package by inheritance. So it's so important. We will discuss this. Before that, let's just discuss about the keywords. Final keywords, static keywords. What are final, what are static? And I think, yeah. Then we'll come to polymorphism, inheritance. Okay, so why do we for example, let me just make all this public. Let me make this public. Okay, now if I wanted to make final, if I use a final keyword is used to make this constant variable, which means we cannot change the value of this. For example, the value of this is 30 or 54. Okay, the value of this is 54, and also I cannot change this. Just cannot do this. It will return 0, let's say. Okay, it doesn't do anything. So the final means that after putting this final, what will it do? It will make this whole variable constant. So the variable is integer, name is age, and it will be a constant variable. I cannot change the value of the variable. Okay, For example, let me show you. H1 dot h is equals to 34. If I just say I want to change this but I cannot change this, it's saying that remove final modifier. Cannot change this. So this is final. Okay, so this is final. What is static? Why do we use static? Use as constant in Java, preventing to change value by constant function. Can also use final in inheritance. We will discuss this later. Inheritance. So static, what is static? One shared copy of data in function. Static, whenever we try to put static to a variable, it's static means that you are creating a memory inside a class, within a class. Okay, so this is my class human, and I'll just put static int age. So using static keyword I can create objects without I can just access these variable without creating an object. Okay, never make objects independent of object. I can access these variable, I can access these methods without creating object. It belongs to the class now, it does not belong to the object. Ownership of the data belongs to the class. In order to access static members or function, I'll just put dot and I can access these either attributes or either functions or methods. Always call with the reference of the class. Using the class name only, the class space will be shared by to all objects. It can be shared to all objects. Okay, discuss. Static members function in a class can also be accessed by another class. It can be accessed by another class. Let's see how. Let's just understand this static. Now let me just make this static. I can just say static final, or let's just put static for now. Static. Also this one is static as well. Now there's no need to create there's no need for me to, okay, it says remove h1 and all assignment. I need to remove, no, it's different. H1 dot, okay, now there's no attributes like name and age because it's now the memory belongs to the class, so no need to create this. I will just say human dot age is equals to 45 43, and there you go. I have accessed the attributes but just by putting the name of a class. Why? Because I put the static. This is the meaning of static. And then at the same thing I can just put static in here as well. If I put static, okay, then human dot, and I can get the method as well. Okay, this is the reason why we use static keyword. So this is why we use static. Whenever we cascading, so cascading to identify which keyword is being used into the method, into the variables, into the attributes or method. If the cascading is complete capital, then we can say that it is written in case capital, means that it is static. Okay, if it is written like N is capital, O is capital, and C is capital, camel case, which means this is final. So we need to know this stuff. Okay, whenever we need to identify that which is static and which is final. For example, if I just say integer dot max value, this is static, and this might be, for now I can just see that these are all static because they are all in capitals. So same thing goes for final as well. Let's move on. Okay, so access modifier, now polymorphism and inheritance. I think I'm going to create another video for this. So for now, it's enough for today. Okay, we will discuss this inheritance, polymorphism, interface, abstract, exception handling, and file processing.